Welcome back. Let's take a look at Chapter 13, Section 2, where we find outliers. And they're actually going to mix in the idea from 13.4 about a box plot to explain it, but how do we identify an outlier? So you'll notice in your textbook, it gives a definition. An outlier is a value in a data set that's much greater or much less than most of the other values in the data set. Outliers are determined using the first or third quartile and the IQR. So fortunately, you all know what the first and third quartiles are, and you know what an IQR is. But just in case you forgot for the moment, let's refresh your memory by, let me shrink this down a teeny bit and go over to this graph. And I have these points that are graphed here. These are the points 2, 3, 3, 4, 5, 5, 6, 7, 7, 7, and 12. And we just said an outlier is one that's far away from all the other points. So my question is, over here you see the number 12? Is that far enough away to be an outlier? That's what we want to know. Is this an outlier way over here? Because it's not like all the other ones. All the other ones are together in a cluster, and this one's on the end. So to figure that out, we need to know what the IQR is. So if I push the box plot button, it's going to show me a box plot. If you recall, the IQR is the distance from quartile 1 to quartile 3, which is shown on a box plot as the ends of the box. So from the beginning of the box to the end of the box, how far is that? It's 7, take away 3, or you could count 1, 2, 3, 4. It's 4 units. So if the IQR is 4, let's look back at our definition. What's the definition? It's 1.5 times the IQR. I'm not exactly sure why they picked 1.5, but they did. So let me open up a quick whiteboard. So we said the IQR was 7 take away 4, which is 3. Sorry, I did that wrong. 7 take away 3, which is 4. That was from the beginning of the box to the end of the box. And then they have this definition is 1.5 times the IQR, but we just said that's 4. So 1.5 times 4, which is 6. So, building on our understanding, if we go back to that graph, which is right here, if I go 6 units above the third quartile, 1, 2, 3, 4, 5, 6, that's the beginning of any outliers. They'd be over here. Or 6 units below this one. So I happen to have graphed that. If it's over here in this green section, it would be an outlier. Or if it's over here in this purple section, it would be an outlier. Well, is the number 12 in the green section? No. So it's not an outlier. If it had been the number 14 over here, then it would be an outlier. But it's just within, I call it the boundaries. That's just a word I made up for that. Not necessarily the math definition boundaries, but that's what I call these lines over here on the ends. So, just quickly running through the presentation that we had. What is the IQR? From the first quartile to the third, it's 4. And then here's a quick explanation if that helps you. What are the boundaries? 1.5 times the IQR above Q3 and below Q1. So it'll be 7 plus 1.5 times 4 is 13. So in other words, if a number is greater than 13, it's going to be an outlier. And the lower boundary is 3 take away 1.5 times 4, which would be negative 3. So if it's less than negative 3, it would be an outlier. So the upper boundary would be 13. Lower boundary would be negative 3. And so since the number 12 is within the boundaries, yes, which is a little bit confusing because I didn't ask you, is it an outlier? If I said, is it an outlier, you would say, no, it's not an outlier. All right, thanks for listening.